All right, we're back with another project here. Um, much like if you saw my last video, this is much like the same one of the other video, but this is where OSPF is more on steroids, if I would say. We're working with multi area multi area OSPF, and along with that internet VLAN routing on top of that. So I did a config again for this here. Before I do that, let me actually just show you that we have DHCP also on DHCP server, and I can show you that it will work by changing this to static to DHCP. Right, DHCP request successful. Right, I believe I'm not sure what the IP address is, but 3.11. Okay, I'll just do is and then 3.11. I'll just do is just go. First one's gonna fail. Warp. Rest should that's all. Do a simulation, then run it again throughout the network. There, I was back. There, even works for this one right here. PC, I'm gonna do CT 11 14. Doesn't have an IP address. Do the DHCP. Uh, oh, successful. I actually could show you the whole request too for that. Let me get down. Whoa, whoa. I was wondering why it was freezing. They're eventless. Okay, maybe I can't really show you on the simulation part, but it did get an IP address. It did get an IP address. It was said successful. Um, this one is 16.11, so I'm gonna do a PC1 again. PC1 like 10. 16.11. I said first one will fail because of ARP versus successful. It will show you the relation again. Goes to this router. Goes down like so. I'm actually gonna. Oh, I'll take another screenshot later. But essentially, for this whole project, right? I already explained this in the other one, so I'm gonna make this a much bigger. Uh, with the switches, right? We're basically creating VLANs and creating an interface VLAN as well, and putting IP addresses for both of these layer 3 switches, which we have two here. We have two, one here and one over here. We're basically creating VLANs for them and creating putting IP addresses in them, right? And then doing IP routing for them because they both have both layer 2 and layer 3 capabilities. Put an IP router at the end, and then so these two VLANs will be able to talk to each other. These two VLANs should be able to talk to each other. They can, by the way, right? 3840, right? Same thing. This is the same thing as the other switch. Same thing as the other switch over here, right? And actually, just you know, no bullshit, no bullshit. That this obviously does work, right? I'm gonna ping it on the other thing. First one fell because of ARP. There you go. It's essentially the same configuration. Copy it, change the numbers around, and that's about it. Um, but yeah, that's that done. For this one, right? For this one, for the bottom one down here, the trunk, right? For this one, this is actually two like regular like multi-layer switch ones. This is actually a router on a stick, right? So essentially, in this case, the only difference here is that we'll create the VLANs, have the ports onto their obviously switch port mode access and within their respective VLAN. The only thing difference is that for this one interface right here that's going up to the router, just put this in a trunk port because you need to send it to them. And then for the router, you need to do in cap with the .1Q, which is VLAN tagging. Put the 50 and then put a 60 for both of these. Bring up the port with no shutdown, and then also do it by .50, .60. And this right here is essentially you're creating a sub interface for this for you, and then IP routing and then right. And that's about it for the whole VLAN section. Uh, OSPF. This one I actually got trouble with, but I figured it out. Essentially, for here, from here, R1, which is this one, you can we gave me an IP address, right, and bring it up. Then R2, which is the main one. This is where everything is being rejected, and this is where the HTTP is gonna come to play later. You essentially need two routes, right? You need two routes. Essentially, you need one route to talk to all the routers, and then you need one route to actually talk to the respective 192 and 168 networks, right? VLAN, the VLANs 10, 20, 30, 40, 50, right? That's essentially what I did. So the R2, right? I essentially created OSPF, gave it a route ID as 001, and I advertised both of these, right? Because this one is connected to both of these routers, right? And connected to this DHCP server. And it's also since this is also around on a stick, right? It's also connected to this switch and it has this. So that it should be able to advertise everything, right? From not only the 10.0 networks, but also 9.2. I have this on the area 3. You don't have to put it at area 3. You can put it. I'm pretty sure you can put it area 0. I just have it in a whole different area, and then for these other interfaces, I just have it like with the respective IP address. So yeah, R3 same thing. 3.3.2 um which this interface, the serial interface 0.021, same thing. And this is the right, this one's the point one, this other one is point two. Right. Area one, which is this one, this between the layer three switch and the R1. Essentially I just have it advertised with this right here. 10.1 network, area one. So this is its own internal network. And then 2.2, which is area zero. I would say in some way or form, we could combine this and make it summarized. I basically did this to make it more like obvious of how it's played. This route is for the communication to the layer three switch. This one is for the communication to the R2. That's it. Same thing for this one. Same thing for this one. Well, oh yeah, I also gotta show you this one for the multi-layer switch. You gotta keep in mind it needs a route to talk to the router, and then it needs a route to talk to the R1. It needs a route to talk to the switch, the layer three switch, and it needs a route to talk to R2. Keep that in mind, right? Switch two, or area two, it's the same concept. It needs a route to talk to the R3 router, and then it needs a route to talk to VLANs. Same thing R3, one to talk to the one to talk to the layer three switch, and one to talk to the R2 router. As long as you're able to do that, um, everything should be able to advertise. I can show you by um this. If I do show neighbor show IP OSPF neighbor, you see 6.6.26, which is 10.1.1. It's a multi-layer switch, and then 2.2.2, which is R2 route. And we could do this. Show show the neighbors. Remember, the switch here is a members layer two, so doesn't count. You should only see two, right? Server doesn't also count as well. Uh, these are in both in full states. 5.5.5, which is the one on 021, which is this one R3, and 7.77, which is 0200, which is this one R1. 10.2, 10.2, right? And they're both in full states, so everything is working. I showed earlier the simulation part, right? Get the notepad. Uh, um, yeah. So that's basically it for the OSPF part. Um, for the HCP, which is its own separate thing, the only thing you would need to do is do the Albert address, and this is so that PC can find its own final DHCP server. All these are uh 10.5.1, which is basically the port over here is 10.5.2. So and for RTL, you're basically giving this IP address, and for all these VLANs and every single including the router, because this one actually has the .50. It's an interface, right? You will give the IP helper address, right? On the DHCP, because we I don't know if I don't know if you catch everything online how like switches and um give it address, give it a subnet, um subnet, give it a subnet as well. I have it a point to point, and this is give it a gateway as well. For services, DHCP, right? Default gateway, which is this is how it's gonna reach out of the network to do all requests. Um, the router, never mind the router, right? This is a DHCP server. It does all for it, but it still needs to get out to the networks. And this the gateway is R2, just 10.5.5.2. I don't have a DNS, so I just left it blank. You'll realize that there's actually 6 poles here, multiple poles. This one's a default one. Don't worry about this. This one right here, these are 6 poles. Um, one issue I actually had, I was wondering why is it not working? Um, for each of these ones, you have to actually label it as the default gateway, right? Oh, I realized I wasn't selecting the right one. So this part right here is actually completely relevant. um, but essentially, for each of these pools, right, you have to match it with a gateway IP address because it's if you don't, it's not gonna be in the same subnet. So 192.168.10.1, that's like uh right here, well, which is in this layer 3 switch 10.1, right? Starting with 10.10, so basically I'm excluding 1 to 9, right, or 0 to 9 if you want. And then giving starting from 10, and every single one of these with the same subnet mask are all it's done the same way. If you don't do this, it's not gonna work, and it's obvious because it's not in the same subnet. If you do like 10 like 5.5 no 10.5.10 like 10, it's not gonna work. It has to be the same subnet, which is the .10. Yeah, that's about pretty much it. Again, I probably will put a paste pin in this config. Yeah, that's about it. Yeah, man.